There are some key differences between classes in Java versus C++. In Java, we can declare static variables as well as instance variables, and basically every single variable that we declare, we would specify if it's static or instance, as well as any access modifiers such as public or private. Then we would also have constructors that we would specify, and we would specify different methods as well. Note that for every single one of these, we specify private versus public on the item that we're modifying itself. In C++, however, we have a public region where we specify public, and then everything created within this region will be public. And we have a private region where everything inside of this region will be private. We don't specify public versus private on every single individual item. We list them in the area for that given access type. So in the public area, we would specify public things. In the private area, we would specify private things. Also, a key distinction between Java and C++ is that in Java, the moment I declare a constructor, I need to actually implement it. And when I write methods, if I declare it, I have to implement the method itself as well. I have to define it. In C++, I can actually, instead of defining methods, I can choose to declare methods. So here I've declared a constructor and I've declared two methods, but I haven't defined their actual implementations. And then outside of the class, I can actually implement each of these methods, and I can initialize static variables. So here I'm initializing the int variable that's in the student class, and it's called numStudents, and I'm initializing it to 0. And I'm also in the student class defining the student constructor that has a single parameter type string, that's this one here, and I can actually implement it. And then, there's a method with return type void in the student class called setName, which has one parameter of type string called n, and then I can actually implement it. And same goes with getName. So I can actually define things outside of the class that I only declared within the class. Whereas in Java, the moment I declare a method or a function, I have to implement it on the spot. One super convenient feature that C++ allows us is the member initializer list. So traditionally, if we write a class, we might have some private instance variables that then a public constructor would initialize. And this type of syntax you might have seen before. We have a constructor, it takes in those parameters, and then we just basically line by line initialize our instance variables. Because it's so standard for us to want to initialize instance variables based on the value of the arguments, C++ has this nice feature called the member initialization list, which is right here. Basically, for each instance variable, we can put the instance variable, and then in parentheses, we can write which parameter we want to use to initialize it, and then it'll initialize the instance variables for us. So now my constructor itself is empty. I don't do anything in my constructor because all of the instance variables were initialized using the member initialization list. A key distinction between Java and C++ is that in Java, we would write all of our code for a given class in a single file, the .java file. In C++, however, we have source files and header files. Source files usually have the file extension .cpp for C++, and header files usually have the file extension .h. So let's imagine this is our student class that we want to implement. In this example, I've written it all in one file. So we have the class declaration where we've written the public and private sectors, and we've declared a static variable numStudents and a constructor that we've declared but we haven't defined called student, because it's a student class, and we've declared a private instance variable. And then outside of the class, we initialize things as needed. The more C++ way to do this would be to actually separate out my code into a header file that contains just the class with the declarations of everything, and then a separate source file. So this was the header file. And then have a separate source code file that actually has the implementations of everything that I declared in the header file. There's many reasons for this, but one big reason is that if you want to share your code with somebody, you have now your declarations completely separate from your implementations. So you could send someone just the header file, and they could see exactly how to use your program without having to worry about how the specific details are implemented.